As a remote technician, I can use a ThingWorx IoT application to monitor the health of wind turbines running worldwide. The cards on my monitoring screen represent different wind turbines that are running at various wind farms in the United States. These assets are reporting sensor data through Kepware, which is then sending the data to our IoT remote monitoring application that's built on top of ThingWorx. With out-of-the-box IoT building blocks like the Kepware Connection Helper, these assets were easy to connect and configure, so that we could start retrieving valuable product usage data. From the monitoring screens, I can expand different regions or asset hierarchies. As a remote technician, I've recently received a high number of automated alerts that were generated from machines in the Southwest region. From the Search and Filters panel, I could also filter down by status. In this case, I'll filter down to any asset that has an active alert, where we can see those same assets in the Southwest region. Because this alert is happening on multiple assets, it could be an indication that there's some unexpected usage that is pushing the asset over its design limits. Using roll-up reporting, we can further investigate by comparing the assets reporting an alert against all the connected wind turbines. From the Performance tab, I can see that the performance for these assets is only slightly lower than the average but that the blade RPM is higher than the average. In the Maintenance tab, I can see that the high vibration alerts are occurring at a significantly higher rate than the average. And I can see that the amount of ServiceMax work orders are also higher than the average. In the Environment tab, I have a roll-up of all weather factors, including wind speed and the amount of wind gusts detected. From here, I notice that the high vibration count is increasing along with wind speed. In the Product Roll-Up tab, we can see the percentages of makes and models that are reporting the vibration alert, and that most are coming from Asset Model 162. We can also see that the alert counts for vibration are significantly higher than the rest of the wind turbines. To investigate if there's an issue with the product, I can go ahead and create a problem report, noting the high vibration and low performance issues. This problem report can then be forwarded onto an engineering department. For our demo scenario, the problem report that was submitted resulted in a redesign of the pitch manifold. Once engineering has redesigned the pitch manifold, a service planner will plan the replacement of the parts for all of the assets affected. Through ServiceMax field change orders, we can query and identify all the assets that are in the field that need the pitch manifold to be replaced. The planner can select these assets and generate work orders that can then be assigned to technicians in the field. Using the remote monitoring application, I can also find wind turbines that require immediate attention. Earlier I noted that a turbine in the Southwest was reporting a high priority error, and I can filter down further to quickly find the asset. Selecting on the wind turbine's asset details, I can view all of the data that we are collecting from the machine, including an active alert regarding a switch error. Selecting on maintenance, I can see that the switch's voltage is low and that the switch power supply is reported as off. When I select on alerts, I can see the alerts for the power supply as well as the alert for high vibration. The alerts and data coming from the turbine can also be used to automatically generate ServiceMax work orders. From the ServiceMax menu item, I can view existing work orders, including one for maintenance, as well as a recently created work order that was generated by the system to repair the switch. As a service planner, I'm looking at the work order that was automatically generated from the wind turbine with error code 5375. Before I can assign a technician, I would like to check the different procedures, parts, and tools required by the technician before he goes on site. For that I will click the search documentation link on the work order that will direct me to the replacement of the Cisco switch. When I click on the link, I'll see more details on the technical manuals for the switch. I can check all the tools, parts, and consumables required along with the procedure and process on how to replace the switch. So, I can verify the technician has the right parts and skill sets before they head out and ensure they do the job right the first time. This helps improve the first-time fix rates and lower the mean time to complete by the technician. I'm now going into my service board, which shows me the schedule for a 2-week time frame of all the technicians I manage. For this job, I'm now going to use one of the capabilities of the service board called Recommend Resources to find a technician with the right skill sets and parts required to complete the job. When I click Recommend Resources, the system does an analysis which indicates that Terry Butler is a 76% match to the requirements of this job. This means Terry Butler has the right parts, skill sets, and product expertise to complete the job successfully the first time. I can easily drag and drop the work order onto Terry's schedule, and he can now work on this while he's still on site at the wind farm. I can also check the route that Terry will be taking to arrive on site. This helps me make any scheduling adjustments and avoid unnecessary travel by the technician.
Now that the work order has been assigned, the field technician on site at the wind farm can begin implementing any required repairs.